Good evening, everybody. I got this simple looking equation, but it stumped me for a little bit because it's one equation and two unknowns. The unknowns are A, B, and C. And I went ahead and imposed the conditions that we would get A, B, and C from the positive reals. That's what we mean by the Q plus here. Find solutions A, B, and C, a member of Q plus, positive rationals. I'm sorry, positive rational numbers, positive fractions. Now, that may be superfluous to actually impose that condition, but I was thinking maybe you could have a negative fraction offsetting a positive fraction and still get a positive fraction. So I'm not sure about the answer to that question, but anyway, we're trying to find rational solutions here. Now, I found this problem at the Root to Mathematics website, Math Channel, and it's a nice little problem. And again, it stumped me. I tried to consolidate this into a single fraction, and I guess you could solve it from there, but it's unnecessary. It's more straightforward just to do a division, which is what we do in this step right here. Let me get the marker working here, the pencil. All right, now, so certainly 73 over 11 is 6 plus 7 over 11. That's just a division. 6 times 11 is 66 plus 7 is 73. So we got the quotient, remainder and divisor right here. But by identification with this top part, we get that A is equal to 6, and we set 7 over 11 equal to this piece right here, okay? And so when we do that, we get this fraction is equal to this fraction, so that means their reciprocals are equal to each other. In other words, we just inverted the left-hand side and the right-hand side, which is just follows from properties of equality, I suppose. And in any event, you can see right here, you can, yeah, I'm sure I'm doing too much here, but you can write this 7 over 7 plus 4 over 7, right? Of course. And 7 over 7 plus 4 over 7 is equal to the 7 over 11 that we are equating it to. And that implies certainly that B is equal to 7 over 7, or B is equal to 1. And this part was a little slippery. 1 over C is equal to 4 over 7. 1 over C lines up with 4 over 7 right here. And so C would actually be the reciprocal of that. And we recorded the answer on this next line. Now, I think that at Root to Mathematics, they just did integer solutions, and they didn't really name the number system they were working in. They just used the letters and then said solve it. And it's nice. And I think the way they did it, they did a division, two divisions to get the result. This resulted in I think just one division overall, right? Was it? Yeah, I guess so. So in any event, I thought it was kind of a fun little problem, because in my mind, if I see one equation and three unknowns, I think, oops, not enough information. But I guess just I don't know if you call it the division algorithm or just the structure of division allowed us to solve it, So it's kind of tough to you stick to these rules that you learn. Like if you have one equation, one unknown, you can solve it. Two equations, two unknowns, you can solve it. Three equations, three unknowns. And so it's always stuck in my mind that if you just have one equation and three unknowns, you're going to have a hard time with it. But in this case, it worked out rather nicely. Let me know what you think.